Hello and welcome to this video all about AQA pseudocode. So really I'm aiming this at people who have sort of just about finished studying AQA Computer Science, in particular GCSE Computer Science. This video is aimed at people who are just finished because I'm not going to go through all of the concepts from beginnings in this video. It's really aimed at just a revision tool, hopefully clearing up any final misconceptions. Now, before you start potentially panicking about the length of this video, I want to be really clear that pseudocode is just fake code. You have not got to learn it, right? It's not something you've got to memorize and learn and be able to recite in the same way that effectively you've got to do that with the programming language you have learnt. So you've got to know Python syntax or C# syntax or Visual Basic syntax. Pseudocode, not quite the same thing, right? Because when you write pseudocode in the exam, you can do it in your own way. So please don't feel throughout this video that you've got to write it in the way I'm going to show it. It's not like that. Python, to an extent, yes, or C# or Visual Basic, but not pseudocode. Okay, but crucially, there needs to be some consistency and there needs to be some connection to a language so that every programmer would be able to understand it. The person marking the exam must be able to understand it. Now, the purpose of this video is to really compare how AQA are going to present pseudocode versus program code. Because in paper one, as hopefully you know, some questions you have to answer in program code. It will say, write a Python program, write a C# program, and so on. So you haven't really got a choice with how to answer those. But there might be a few which let you answer in pseudocode. Now, to be clear, you could answer in program code. You can answer in any way you like, but it has to resemble code, but it can be a little bit fake. You do not have to follow AQA pseudocode, but it's not a bad idea to borrow some of the constructs if you want to. But what I think is important to realize is AQA are going to show you examples in both pseudocode and program code. And so if you don't really understand how the AQA pseudocode works, that's not helpful if you're aiming for the top marks in the test. So really this video is aimed at trying to increase that understanding so that you can not have to think too hard about it in the exam. And when I say AQA pseudocode, it kind of goes against what I said about it being variable and it can change. AQA have defined their own, it's almost like a programming language here, they've defined their own syntax for pseudocode, which doesn't really make sense, but they've done this understandably because it would be not very fair if every year they presented slightly different pseudocode. So they've published a document, which I'll link in the description, which outlines how they're going to present pseudocode. So what I'm showing in this video is taken from this document. Again, you don't have to learn it, but really understanding it is fairly important. So let's go through each of the key programming topics and compare AQA pseudocode to Python code in the main. I'm doing Python because it's the most common language GCSE and I think it's the simplest to look at basically. So starting with variables and constants. If you're not sure what these are, please go away and look at my video which covers this from beginnings. This is just a kind of revision video essentially. So on the left here is how AQA will deal with variables. On the right is how Python deals with variables. So the key difference is really visual here. You can see that AQA will use an arrow to show assignment of a value. Assigning a value is giving a variable a value. My city has been assigned the value London. Now their strings will tend to be given with single quotes. I like to use double quotes in Python, but that's not very important. Now the name, the identifier, has to be one word in both language. I say language in both representation, but the arrow is the key difference. Python uses one equal sign, not the arrow. Now that last line, plus equals, is just shorthand for something like my age equals my age plus 5. Now constants are different to variables because they don't change. Once you have assigned a value, it can't change. And to differentiate between the two, we usually capitalize identifiers for constants, so the name of a constant is in capital letters, but also AQA will make this even clearer by writing constant before they assign the value. In Python we can't do this, there isn't a constant concept built in, but there are in other languages like C#. So just for your context, if you're learning Python, in C# they do something similar. They've got a constant keyword before you assign a value. And just on another point which you can't really fully appreciate having learnt Python, but in C# and Visual Basic, you've got to, before your identifier, do something like int and double. Int and double are both data types. A double is a real or a float in C#. This is us declaring the data type of that constant to be a integer and a float. We don't do that in Python, but that's what declaration is, giving a data type to a variable or constant. Now, getting input and output right is, like variables, very, very important because it's going to be needed in pretty much every question you're going to have to actually write code for. So AQA will show user input as the variable name, arrow, user input in capital letters. They won't put a message next to it, but you could if you were writing it yourself. And showing stuff on the screen, outputting, helpfully is called output. In Python, that's what print is. So print is outputting. Print and input are functions in Python, and so we've got to have brackets around them. But in AQA pseudocode, they won't have brackets. Not that that's particularly important. Now, just some advice I would give. When you're writing a program in class, it's a good idea to have a message in the brackets of input. That's called a prompt. So you might say name equals input, enter your name. In an exam, I would not suggest writing a prompt unless it specifically asks you to say a particular message, because you could waste your time being like, hello and welcome to my program, really good to see you, please enter your name, thank you so much for entering your name. You could be really detailed and polite, but actually in an exam that's not a good use of your time. So leave the prompt blank would be my suggestion most of the time. And just another similar point, no real need to cast when you're writing pseudocode. Casting is where you are converting the data type. User input is a string by default, and so you might want to cast it to be a real, which is a decimal number, or an integer or something like that. But in pseudocode that's not important, although AQA might use these following function names to represent this. Not something to worry about, but if you see something like string to real, into real, etc., that's just casting. It's converting the data type. Now, there are lots of operators. I covered a full amount in my paper 1 playlist, but here are just a few which are worth pointing out, I would say. Now, in pseudocode, AQA will show the less than or equal to signs and greater than or equal to signs like you would in maths, with the line underneath showing that it's not just exclusive, that it's inclusive. But in Python, we don't do that because we haven't got the key easily available to us. So we do the less than sign followed by an equal sign, and flipped around for greater than or equal to. Now, because one equal sign was used for assignment in Python, it uses 2 for a comparison. The comparison in AQA's version will be 1 equal sign. So that's a key difference. If you used 1 equal sign in Python code for a comparison, that would potentially lose you a mark. And likewise, not equal to, we can't really access that key very easily. So in Python, we do exclamation mark equals for not equal to. Now, mod and div can be a bit confusing. So mod is giving you the remainder from a division, and the % sign is what is used for that in Python. Now, div looks like a short for division, which it kind of is, but div on its own will be integer division. Normal division, which is also called real division, will be 1// in AQA pseudocode, but div will be the integer division. Now, that just gives you the integer part only. So for example, 9 div 2 would give you 4, not 4.5, which is what real division would give you. Python doesn't have div as a keyword, it has 2 / representing integer division. And a very minor thing, because it's not really marked in the exam, but capital letters are usually given by AQA when they're dealing with Boolean operators, but in Python you use them as lowercase. Now, when you hear selection mentioned, think if statements. Selection is where you're choosing what to do based on a condition. Let's say we've got a really simple problem where we're asking the user for a test score and outputting their score. Let's say above 60 is a pass, so really 61 or above in that case. Between 40 and 60, inclusive, is a near pass. Inclusive means you are using those numbers in your range, so we're including 40 and 60. And let's say below 40, so 39 and below, is a fail. Well, hopefully you'd be able to code this in either Python or represent it in pseudocode. Well, here's how AQA would probably represent this. User input we've covered before, but here is our selection block. So we've got if, else if, and else. Now, what AQA will do is usually capitalize their keywords. So if is uppercase, else if is uppercase, and so on. They put then after the condition. Whether that's needed I'll leave it up to you to decide. But the condition has got to be Boolean. So the first one, score is greater than 60. Let's just output pass. It should be indented. Always indent your code, even if it's not needed. If you're learning, say, C# or Visual Basic. In Python, it is needed, but it's just good practice anyway. Now, else if, which you might know in Python as being elif, is just when you are giving another condition to check. Again, we are in AQA are going to write out the greater than or equal to sign like you would in maths. In Python, we've got that equivalent version. And then else, we haven't got a then after else, not that that's particularly important. And they like to do end if at the end. The benefit of end if is, if you haven't indented, end if shows that block is finished, but it's a little bit overkill if you've got indentation as well. Python, we don't do stuff like then or end if, we have colons and the indents only. Else if, it's combined to elif, these are lowercase. Notice how I've got int in my first line. Because user input is a string by default, and I'm trying to compare it to a number, I've got to convert it to be an integer. That's a mark people sometimes lose. Sometimes because they forget it completely, or they mix up int and input. Some people put input first and then int second. It's got to be in this exact way when it is a whole number, when it is an integer. If it was a decimal number, you'd put float bracket input. So learn that. It's going to be used a lot in the test. Now, what else is worth pointing out here? I think let's just go through what happens in the selection block. So if is always checked. Every time you've got an if statement, that is always going to be checked. Elif has to follow if, it can't be on its own, and else ifs or elifs are only checked if previous conditions were false. Right? Let's say we got 65 on our test. Well, score is bigger than 60, and so we print pass. We would not also check the elif because that first condition was true. So it skips the rest with elifs. Likewise with else. Else is only checked if all other conditions were false. So we'll only print fail when we have tried and not met any of the other conditions. So that sequencing is important to understand the difference between if and elif. And you can have several elifs or else ifs, that's absolutely fine. Okay, moving on to iteration, and we've got two types of iteration, definite and indefinite. For loops are really our only example of definite iteration. We know how many times they're going to loop. So here's how AQA will present for loops to you. If I go something like for I is set to 0, to 10, step 2. You might not always see step 2. If there isn't step 2, it will just add 1 each time. But the step is how much it's adding each time. And like with if statements, they'll do end for just to show that it's ended, but they'll indent the stuff inside the loop. The stuff inside is what is going to get repeated. So here's the equivalent in Python. For I in range, bracket 0, 11, 2, colon. So no end for. Now what this is going to do in both examples is output the numbers 0, 2, 4, 6, 8, 10. I is a variable used just in the for loop. Initially, I is set to 0, and each time the loop repeats, we're adding 2 to I. So I0 then becomes 2, then becomes 4, then becomes 6, and so on until we get to 10. We don't include 12 because 10 is set as the upper range in pseudocode. Now, this is where Python is different, and so you've got to be on alert if you're learning Python. The for loops in AQA are inclusive. So 0 is where you start, 10 is where you end. And step is optional, but it's how much you increase each time. In range, the upper range is exclusive. So we do start at 0, but we don't end at 11, we end just before 11. So you've always got to do one more than you need when you give it an upper range. And the step count is an optional third value you can put in. You can just put in for I in range 11 and it'll go from 0 to 11. This third number is optional. By default it will be 1. Now there's also another type of for loop which occasionally people make mistakes with. Here we have a for loop where it goes through each character in a string, or each item in an array. So for example, for character in string will give you each character in that string, one by one as it goes through. Python code is basically identical, just lowercase, for character in string, print character. Now, I is conventionally used. You could use anything in place of I, as long as it is a single word. I is a number when you've got range. I is not a number when you've got a for loop like the one at the bottom. Okay, so you've got to be careful. Some people go something like for I in string and expect I to be an integer, to be an index number, but it's not. So if you want a number, use for I in range. If you just want a character or an item, use for something in something. Right, the second type of iteration is indefinite iteration, where we're not quite sure how many times it's going to loop ahead of time. And while loops are the first example of this. Here is a simple password checker. A while loop works by looping while the condition is true, hence the name, right? So here, we're going to keep looping while password not equals hi123. As soon as it does equal hi123, we're going to end the loop. So they loop while the condition is true. So here we are telling the user they're incorrect and asking for the input again. That's really important. You've got to make sure inside your while loop you've got a chance for the condition to become false. If the condition is always true and you haven't got a break or something like that, it's going to become an infinite loop. The equivalent in Python is very, very similar, just with different symbols and no end while in this case. So not really much more to say about that one. The one which is maybe trickier, especially again if you're learning Python. Now Python's great, I love Python, but there are a few concepts in the course which are not really fully supported by Python. And repeat until loops are one of those examples. So repeat until loops are another example of indefinite iteration. They can be used in place of a while loop. And there are a few key differences. So this is not quite the same example, but very similar. We're going to repeat this code until the password equals hi123. So we're going to say enter password, they type in the password. We're going to keep looping until it equals hi123. So not quite the same. We're not saying incorrect in this example. The difference is a repeat until loop loops while the condition is false. So it's waiting for this condition to be true. I tend to think of it as while loops are quite negative. They keep looping until the condition is broken, whereas a repeat until loop is quite positive, it's quite optimistic. It keeps looping until it becomes true. So the conditions are flipped, basically. And the other key difference is the condition comes after the body of the loop. A while loop has its condition right at the start, which means the body might never run. If this condition is false in a while loop, it's not ever going to run straight away. Whereas a repeat until loop always runs at least once, which is another key difference. It always runs at least once, then it checks the condition. Now in Python there isn't this direct support, unlike in C# and Visual Basic, but this code is effectively the equivalent. So you can do a while true loop, which would ordinarily be infinite, but if you have a if statement at the end, that's sort of simulating that final condition, and break is a key word which is good in Python, is really useful. Break will end the loop as soon as you hit that. So if you want a direct equivalent in Python, this would be it, but you could just make it into a slightly different while loop with a condition at the start. Moving on now to some of the trickier stuff. So subroutines, we've got two types of subroutines. A subroutine is a block of code which you could be asked to define in some of the longer mark write a Python program questions. So function returns a value, a procedure does not. Here is how a function will get shown in AQA pseudocode. So you might have to interpret something like this, maybe in a trace table. So we've got our subroutine definition at the top, and we start by saying it's a subroutine. So subroutine, we're not saying it's a function, but you know it's a function because it's got a return value somewhere in the definition. So this is for finding if a number is a factor or not. We're using mod to do this, returning either true or false. So that's our definition, subroutine, end subroutine. Now, the definition on its own isn't run. to run the code, you've got to call the subroutine, and I'm calling it down at the bottom. I'm writing the subroutine's name, its factor, and passing in 2 arguments to it, 10 and 5. So 10 is what num1 is set to, num2 is set to be 5. So num1 and num2 are called parameters. You don't always need a parameter or multiple parameters, but these are like inputs to the function. And because I'm only returning, I've got to output to show anything on the screen. In Python, it'll be similar. We get true, by the way, because 10 divided by 5, 5 is a factor of 10, so we get true. The Python code is similar. We use def, not subroutine, to start off our definition, and mod, as I said earlier, is a %sign. Now, to convert these into procedures is really quite simple. Blink and you'll miss it. So procedure does not return a value is the difference. This is just where you want to repeat some code several times. Generally they're less useful than functions, but the difference is not that important for an exam situation. Although you can see we're not returning, we're often just printing instead, just showing the value straight away to the user. And when we're calling it, because the print is in the definition, we don't have to actually output it ourselves when we are calling it. Now moving on to data structures, and there are 2 you've got to know for this qualification. There are lots more when you go to A level, but arrays are the first type. Now arrays, where you've got a group of related items of the same data type. A data structure is just where you've got lots of similar items grouped together. So an array in theory and in most other languages, you've got to have the same data type of all of your items. And that's how AQA are going to present it. So all of your items are going to be strings, or all are going to be integers, or reals, or booleans. They're going to be consistent. So this first line, array1d, is assigned the items hi, hello, hey. So the list has got square brackets around it, and the commas separate out items. Now, to access items, we index it. Indexing is following the name, putting square brackets, and a number. The number represents the position of the item. So the line 2 here, output array1d index 2, is going to give us, well, hey, because we always start counting from 0. Hi has got the index 0, hello has got the index 1, and hey has therefore got the index 2. Now I say we always start counting from 0, occasionally they might change it, but they'll say they're counting from 1. So make sure you read all questions fully in case they switch that. But assume 0 indexing by default. That third line, output len array1d, len will just find how long the list is, how long the array is, how many items it has. So here this is 3. Now the second half of this pseudocode is where I'm getting 2D arrays. A 2D array is just an array of arrays. So this one, we've got array1d as our first item. Well, array1d is an array, and so therefore it's 2D overall. But I've also got a second item, which again is another array of 2 more strings. So to index a 2D array is the same idea, just of 2 index numbers back to back, so 2 square brackets back to back. Now this second line of this second half, array2d index 1, index 0, is assigned goodbye, is just changing by to be goodbye. Because this first index number is getting the list, is getting the array. So index 1 is by and cu, that array. Index 0 is array1d. They're then going inside index 1. Index 0 is by. So we're kind of like going in one by one as we go through these index numbers. And finally, I'm going to output it. So this is what we'd get. In the final result, we get hey from index 2, 3 is the length of our first one, and that's our final 2D array. Now I'm using list, I'm saying list by mistake because I'm so used to saying list, having taught Python. So in Python, we haven't got arrays in exactly the same way. We have lists. Now lists are, in effect, identical to arrays. Like the pseudocode versus Python here is very similar. I'll let you pause and read if you want to. But a list in Python is not as picky. You can have mixed data types in Python lists, but in the exam, arrays are going to be one data type only. Now, to slightly get around this, AQA have also put on the course another data structure called a record. You might recognize record from SQL in paper 2. So a record is a data structure which can have items of different data types. So similar to lists in that sense, but they look quite different in pseudocode. So I'm not going to show any code examples of records because it's really an A-level concept. I'm not quite sure why this is snuck into the course, but it is what it is. Here is how AQA are going to show records. So this is where maybe you've got to pay attention a little bit more because it's quite different to any particular language. If you were converting this into a language, just use it as a list or an array. So, a few things to say here. We've got, first of all, a record definition. This is us setting up the general structure of this record. So I'm calling the record dog, I'm giving it a name, and name, age, breed, and weight are the different items which belong to a dog record. The way AQA have chosen to show this is by declaring the data types next door, so after a colon. So name is a string, age is an integer, and so on. So this is just saying what items are going to be in a dog data structure. The next line, my dog is set to be dog, Billy for Bulldog 25.2. This is me giving values to a particular instance of this data structure. So my dog is my record. I'm making it a dog record with the following items. So you can see I've got two strings and an integer and a real. I've got a mix of data types. And I've got normal brackets, and I've got the record, that kind of record name before these brackets. So a little bit more confusing, I'll definitely admit. Now at the end, I'm actually I'm using the items being stored. So we don't actually index records, we don't use an index number, we use their name instead. Now as you might recall from SQL in paper 2, you've got records, which are your rows, but the kind of items within a record are called fields. And so name, age, breed, and weight are the fields, and the field names in particular. So to get, say, the dog name, so I can say my dog is called Billy, I've got to go my dog, which is my record name, dot the field name, which is name. So to get my dog is called Billy, you've got to do the record name dot the field name. Not too dissimilar from SQL, actually. And if you want to change a value in your record, you can do with a similar process. So if I want to change age to be 5, my dog dot age is set to be 5. So I would suggest you being able to interpret records is more important than you being able to write them yourself, but it's the sort of thing which could come up and could really throw you if you've not seen this notation before. And the last thing I want to cover is string handling. And there are only a few examples of where this will turn up on the course. This is just where you're doing little bits and pieces with strings in particular. So if I'm setting a variable myString to be my example, let's say I want to find the position of the letter E. Well, in pseudocode, they will use a function called position. Position, bracket, the string you're looking in, comma, the letter you're looking for. So that's how you'd get the position of E within myString. And the position will be given as an index number, so again, starting from 0. In Python, you've got a .find method. I've not really used this particularly often, but in Python, it'll be myString.find. A method is where you have the variable beforehand, then a dot. Since it's a little bit different, myString is a parameter to this AQA version. In Python, E is a parameter, but we apply it to the object myString. So a little bit different, might be worth jotting down as a small thing to remember. Now, also, so first of all, let's say what E is. So E is capital E is index 0, 1, 2, 3. A space is a character, and so is counted. So E will give us 3, which I can just show you. And a substring is just part of a bigger string. So to get a substring, this is how AQA have set this out. Substring, the first number is where you're starting from. The second number is where you're ending, and it includes that second number. and the third parameter is your string being used. So substring 0,6 gives us my exam because index 0 is capital M, index 6 is M, lowercase m, and so we go between capital M and lowercase m, giving you my exam. So we just start and end at 0 and 6. Python is a little bit different. You can see this bottom line is how Python does what's called string slicing, where you are splitting the string into a substring. So we use square brackets for this in Python, and again we start at 0, that's included, but a bit like range, the upper range is exclusive. So if we want to include index 6, I've got to put 7 as my second number in this square bracket. And we separate the start and end point, or start and end plus 1 point, with a colon. I would suggest if you are learning Python, you try this quickly in Python shell. Just try a few examples of string slicing, because it takes a bit of practice to understand how this works. And a fairly small thing to end on, which could come up, is converting backwards and forwards between ASCII codes. Each character is given an ASCII code, as you'll hopefully know from paper 2. And in Python, there are 2 functions which are useful for this. Ord, when you give it the character, will give you the ASCII code. So you put in, say, A, it gives you the equivalent code. CHR, short for character, char integer, will do the opposite. You give it the ASCII code, and it will give you the character out. In pseudocode, this is done quite nicely, quite in a more simple way. Just code to char, char to code, give it brackets, give it a value, and it will convert it for you. So those are not used very often. There are different ways to deal with that actually, but those are good to use. Again, might be worth practicing those quickly if you are learning Python. So I really hope this video was useful. It was it was kind of a high level overview of actually all of programming pretty much. But hopefully you can see how AQA are going to present it. I'll say again, please don't spend time learning exactly how AQA are doing it. If you understand what they're doing and are able to kind of interpret it in your own language, that's what is really important, all right? And if you're asked to write pseudocode, I would suggest you kind of do it similar to how AQA do it, but ultimately if you make a few changes, that is absolutely fine as well. So I really hope paper 1 goes well if you've got it coming up soon.